Okay, so let's get into it. We are going way, way back to a technology that basically invented the schedule as we know it, the water clock.
And it has this incredible Greek name, the clepsydra.
Yeah, which I love. It means stealing water. Just a perfect name.
It really is.
And for this deep dive, we're going to focus on three things:
Uh-huh.
how it evolved technically, the massive problems it solved, and the huge impact it had on, well, organizing all the human society.
You really can't overstate that last part. But first, you have to appreciate just how much of a mess timekeeping was before this.
A total mess.
I mean, think about the sundial. It's great, but only if the sun is out. So at night or on a cloudy day, you've got nothing. Time just stopped.
Right, and what about sand clocks? We had those, didn't we?
We did, but they were so limited. You get one fixed duration. A 10-minute timer is only a 10-minute timer.
And they were finicky. A little bit of humidity, the sand clumps up, you bump the table.
And your timing is completely off. Exactly. And things like fire or candle clocks, even worse, a slight breeze, a bad batch of wax, and the whole system is unreliable.
So priests trying to time rituals in the middle of the night were basically just guessing.
Pretty much. There was no stability. Time was tied to the sun. It was cyclical, not linear, not standardized.
Okay, so then, boom, the water clock arrives. We see the first real evidence in Egypt, around the 15th century BCE.
And this is the game changer.
This is the first continuous all-weather timekeeper. It works day, night, rain, or shine.
The early ones were pretty simple, right? Like the one from that Egyptian official, a minim hat.
Yeah, just an outflow pot, basically a bucket with a small hole. You just watch the water level drop past markings on the inside.
But that has a huge built-in flaw, a physics problem.
A massive one. As the water level drops, the pressure decreases.
So the water drips out slower and slower.
Exactly. Your first hour at the top of the pot might be, say, 45 minutes, and your last hour at the bottom could be 75 minutes. It's not consistent at all.
So how did they solve that? Because that's a serious engineering challenge.
This is where it gets so cool. Engineers, especially in Greece and Rome, started introducing all this mechanical complexity. They built feedback systems.
You mean like self-regulating systems?
Yes, and they started using gear trains and even early versions of escapements, the very things that make a modern mechanical watch tick.
Wait, hold on. You're saying the components for a modern clock were actually invented for these ancient water clocks?
That's the legacy. These gears weren't just for show. They were there to solve the pressure problem, to keep the flow of water perfectly steady.
Wow.
And it wasn't just them. In China, they were independently developing these incredibly complex, multi-level leak pots, the louke.
Oh, right, like Susong's famous astronomical clock tower.
Exactly, a 30-foot tall water-powered machine. It's just mind-blowing.
So if we connect that technical leap to the societal impact, what happens when time becomes reliable?
Well, everything starts to get standardized. It becomes a tool of power and order.
For religion, it must have been revolutionary. Now priests could time their nighttime rituals perfectly.
And governments jumped on it. In China, they had specialized officials, the qihu shi.
The keepers of the pots.
Basically, yeah. They were the government's official timekeepers, managing the state clocks for all official and ritual business.
And I bet that standardization bled into everything else.
Oh, absolutely. Commerce, for one. You could now have regulated market hours in a city like Chang'an.
And for science, especially astronomy, this had to be huge.
It was indispensable. It let Babylonian and Chinese astronomers make incredibly precise observations, which helped them refine their calendars. And like we said, all those gears and escapements.
They laid the foundation. They were the direct technical ancestors of the first purely mechanical, weight-driven clocks hundreds of years later.
So think about what this really means. The water clock didn't just let us measure time. It fundamentally changed how we conceptualize it.
Right. It's no longer just sunrise to sunset.
Exactly.
Yeah.
It forced us to see time as this linear, divisible thing, something that could be chopped up into neat little packages, hours, minutes, seconds, that govern our entire world today. It all started with just a little bit of stolen water.
It makes you wonder.
So here's something to think about.
Yeah.
We've seen how water gave us standardized hours. What other simple, natural element do you think came next to completely dictate society's pace?